Okay, so now we have a problem set, we have data, and we need to identify things like the median, the mode, the mean, and the 75th percentile. So first thing we need to do is we need to sort the data. So how many data points do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's just sort them again. So we have 10 data points. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The lowest value is the 4. So the lowest is the 4. Put the 4 here. Then we have 1, 2, 5s. Then we have we have 3 5s. Then we have 1, 2 6s. We have a 7. Then we have an 8 and 2 12s. Okay, so this is our data when we sort it. So let's first calculate the mean, and we do the simple textbook formula. So we use the formula where the index number is I equals P times N, so that would be 0.5 times 10. So for the median, it's the fifth. And as you remember, whenever we have an integer, then we have to take the midpoint between the fifth and the next one, but the next one is a 6-2, so we don't have to worry about that one. So the median is 6. So the mode is 1, 2, 3, 5, because we have 3 5s. So that's the most frequent number. The mean is, so now we have to calculate the mean. So this is 4, 9, 14, 19, 25, 31, 38, 46, 58, 60, 70. So 70 divided by 10 is 7. Let's double check again. 4, 9, 14, 19, 25, 31, 38, 46, 48, 58, 60, 70. So that's correct. So now the 75th percentile. So now we use again that formula, and then we get the index number 7.5, not an integer, so we have to round up, and our index number would then be 8, and the corresponding value is 8. Okay, although it is not asked, now we could also sketch a stem and leaf box and whisker plot. So we can do that. Let's say we have values till at 12. So 12, 11, 10, 9, 8, 7, 6, 5, 4, 2, 1, 0. Okay, so now the 25th percentile. We haven't calculated that, but if we look for the 25th percentile, 2.5. So not an integer, so we have to go to the third, and the third has a value of 5. So this would be the 25th percentile, and we already calculated the 75th percentile. That's 8. So this would be the box. Then the whisker is 1.5 of the interquartile range. So the interquartile range goes from 5 to 8. So we have to do 3 times 1.5, and that's 4.5. So maybe we still have here a 13, but then it goes into the middle. So that would be one whisker, and the other whisker would go from 5 to 1, 2, 3, 1.5. That would be the whisker. And then we see we wouldn't have any outliers, nothing would be outside. And then if we still want to, we can say here's the mean, maybe we make a dot for the mean, or let's call it x mean, and we can spell it out. And the median, which was 6, would be here. Median. Okay, so that was a review of the box and whisker plot. Let's see what the next one is. Okay, that's a similar one. It's a little bit easier. But we also have to calculate the sample variance and the sample standard deviation and the coefficient of variation, the range, the interquartile range. Okay, so let's also do this one here. So scenario 2, we have 1, 2, 3, 4, 5 observations. So let's first write that down again. So we have 1, 2, 3, 4, 5, and the corresponding values are 2, 3, 3, 2, 3, 3, 2, 3, 3, 5, and 12. Okay, so what about the sample variance? So the formula for the variance is again S squared. Then we need to sum up all the deviations from the mean and divide by n minus 1. So let's create another column. And call that xi minus x bar. So that means I need to calculate first the mean. So that should be easy. We have 5 observations, so 2, 5, 8, 13, 25. So 25 over 5 gives us a mean of 5. So now xi minus x bar, 2 minus 5, negative 3, 3 minus 5, negative 2, 3 minus 5, negative 2, 5 minus 5, 0, 12 minus 5, 7. And again, the mean is the mathematically most accurate measure of central tendency because all the deviations are equal to 0. Negative 3, negative 5, negative 7, plus 7 is 0. Okay, so now that's why we need to square it. Xi minus x bar squared. So we get here a 9, 4, 4, 0, 49. So what's the sum? 9, 13, 17, 26, So the sum is 6, keep 2, so that's 66. Okay, so now we have here in the numerator 66, and now we need to divide by n minus 1, which is 4. So we have 66 over 4. Let's double check again. 9, 13, 17, 26 plus 40, 66. So 66 over 4. So that gives us now a sample variance of 16.4, because 4 times 16 is 64 and 2 over 4 is 0.5. So 16.5. So the sample standard deviation is, well, it's the square root of the variance, so that must be 4.062, because all the others really don't make sense. So now the coefficient of variation is, so the coefficient of variation is the standard deviation, which is the 4.062 divided by the mean, which is 5. So from looking at it, it should be something close to 0.8. So that must be clearly D. The range is, the range is easy. That's the difference between the highest and the lowest value. So that is 10, 12 minus 2. Okay, so now the interquartile range. So now we need to get the 75th percentile. So that was 0.81. So now let's get the 75th percentile. Okay, so what value do we need? So we take the index number 0.75 times 5. So 0.75 times 5, that is index, so 3 over 4.75 times 5, which is 15 over 4, or 3.75. So not an integer, so we have to round up and take the fourth value, so that's a 5. So that corresponds to a value of 5, because the 3.75, the index number, is being rounded up. So now the 25th percentile index number is 0.25, or 1 over 4 times 5, which is 5 over 4, or 1.25. Again, not an integer, round up 3. So that corresponds to the value of 3. Okay, so now the interquartile range is obviously 2. Okay, so now if we want to, we can still draw again the box and whisker plot. So 75th percentile is a 5. The 25th percentile is the 3. Then what did we say is the mean and median. We said the mean is 5. So let's make the mean, just say x equals mean. Then the median, that would be 2.5, 3. So the index number for the median would be 2.5. We round up to the third, so that is 3. So let's make here so that would be the median. Then we need the whiskers. So the whiskers is 1.5 times the interquartile range, and we put that on top of the 75th. So we have a 3, it goes from 5 till 8. And another whisker that goes down to 0. And now we can also still look for some outliers. So we have a 12. And now we can put a dot here. And so now we would know that there is a maximum of 12, but that is also an outlier. And if we want to, we can also say there's a minimum here of 2, which is not an outlier. So that's the idea of a box and whisker plot. And yeah, so the next question is about a sample covariance and the correlation coefficient, but before this video gets too long, I'll do that in the next one, do a separate video.